What's up, Algebra 1? It's Mr. Knight, and we are starting our next unit, Unit 3, Functions. We're going to look at Level 1, Domain, Range, and Functions, talk about what all those things are. And look, we're going to answer this age-old question. What is math? What is it about, right? We've been wondering what this is, maybe, hopefully, and really, guys, like I've been saying from the beginning, math is all about love. It is. I know it's not Valentine's Day, but math is about love. It's about communication. It's about problem solving. And finally, it's about relationships. And a special type of relationships, which is what a function is. A function is actually a special type of relationship. It's a relationship between values, essentially. Let's write that out. It's a special relationship between values. We're going to put a semicolon. Okay, we're getting a little Englishy on us. Where an input and output are related, but they're related where one input has exactly one output. Okay. Each input has one output. Okay. Let's talk about what input and output really are. An input are your x values. Okay, if you're like looking at a coordinate plane like we did for bell work, the x values are your inputs, your y values are your outputs. So let's write that down. And in fact, those even have more special types of names. An input, or an x value, is also known as your domain. And your outputs are known as your range. We'll call those range values, right? So domain, range, that's all it is. And look, we just defined what functions, domain, and range are. So now let's actually use those and see how we can apply them. So, like I said, relationships can be found in math in a variety of ways. Usually, if you're looking through these examples, we've seen where we have ordered pairs, right? We have an x value and we have a y value right here. X value, y value here, and so on and so forth, okay? But we also have table of values, right? Again, we have our inputs and we have our outputs, okay? Or our domain and our range. And then finally, we have something that looks like these looking oval things with things in them. We call those mappings, okay? These are mappings. And again, on the left side, we have our domain. Right side, we have our range, our inputs, our outputs, our x's, our y's. They're all just related to each other, okay? These guys are called tables. And then, again, these guys are called ordered pairs. So if you need to write these things down, I totally would, just so you know what I'm referring to. So when I say, hey, look at the ordered pairs, you're like, oh, those are coordinates that we're going to plot on the graph. Something like that, right? Really what I want to look at today, though, is using these two tests, okay? These are tests to see whether or not relation is a function. So for given ordered pairs, so like something like this, if the x values repeat, it is not a function, okay? It's easier to tell if it's not a function or it is a function. So for these first two, let's just look at them, and then I'm going to let you guys try 3 and 4, okay? 1 and 2, let's see if the x values repeat. 5, 3, 2, 0, negative 1. We're good. This is a function. If we're looking at number 2, are they going to repeat? Negative 2, 0, 2, 3, 2. They do repeat. This is not a function. And for right now, that's all I care about, is we can determine if it's a function or not a function. Okay? So I'd like you to try 3 and 4 on your own, see what you guys come up with, and go. All right, we're back. Let's see what we came up with. Again, let's see, negative 4, negative 3, negative 2, negative 1, negative 3. This is not a function. The negative 3's repeat. Okay? Let's look at number 4. 1, 2, 3, 4, 5. This guy's good to go. This guy's good to go. This is a function. The x values don't repeat. Now, what if the y values repeat? Is that okay? Totally. Y values can actually have like multiple x values, but x values can only have one output. So again, don't get bogged down in that stuff. Just focus on this when it comes to ordered pairs. If the x values repeat, it's not a function. It keeps it way easier, right? And look, we can actually do it with the tables, but we're going to save the tables 5, 6, 7, 8 for later. So we're going to save 5, 6, 7, and 8 towards the end because I actually want to graph those and I want to use this vertical line test right here, okay? But you also might see functions when it comes to mappings. So we want to take a look at these guys first. Again, we're going to do number 9 together, and I want you guys to try number 10 on your own a little bit. So again, number 9, are the x values repeating? Am I getting more than one line that's coming out of it? -3. Okay, so we have -3 to 0. We have -1 to 4. And we have 2 to 7. And then we have 4 to 4. Again, even though the y values have repeated, the x values did not. Okay, so this guy is a function. This is good. And if you notice too, I was able to create ordered pairs out of our domain and range just like we have up here. You can do it with these two, but really, again, I want you to see that all this stuff is kind of related together. So I'd like you to try number 10. I want you to determine if that guy is a function or not, and go. All right, we're back. Let's take a look at number 10. We got -4, 4. We got -1, 0. And we got -1, 7, it looks like. And right off the bat, I know that is not a function. The x values have repeated. Not a function. Not a function. Okay. I want us now to look at 5, 6, and 7, and 8. Almost forgot this guy. Because you can actually graph these, and there is its own test given graphs where you can use, it's called the vertical line test, where you can tell if something is a function or not. It really just comes down to you taking your pencil and gliding it vertically like this and seeing if a graph has more than one point on it. So if I have a point here, then it will not be a function. We're actually going to see that with number 5 because I'm going to show you how to plot it and create the ordered pairs. So let's take a look at that. Now, what I'd like you guys to use actually is coordinate grid paper that I will provide, but I'm going to be lazy and I'm going to make it myself, okay? I guess that's not really lazy. I'm going above and beyond. Just might not be the most accurate. Okay, everything's going by 1, so I got my positive 1, 2, 3, 4, 5. I got my -1, -2, -3, -4, -5. Positive 5s for the y are up here. -5 is down here. All right. So if we're looking at number 5, again, you can make ordered pairs out of this. We have 3, 5. We have -1, 0. We have 0, 1, 2, 2, and 3, 3. And I can actually plot all those guys. So I got 3, 5, 1, 2, 3, 1, 2, 3, 4, 5 up here. I have -1, 0, -1, and then we're not moving. I got 0, 1. I don't move. I go up 1. 2, 2, over to the right 2, up 2. 3, 3, 1, 2, 3, 1, 2, 3. All right. Now, looking at this guy, I've graphed it. It's totally fine. Now I'm going to glide my pencil. If I glide my pencil and basically it intersects at more than one point, like right there, then it's not a function, right? Everything else was good. It was Gucci up until that point. Once we got here, it was not good, okay? So this is not a function. Did not pass the vertical line test, okay? Sorry, N. There you go. So what I'd like you guys to do, I would like you guys to try 6, 7, and 8 on your own. And we're going to actually conclude class with that. I'm going to walk around, see what you guys come up with, and then we'll bring it back at the end. All right, have a great day, guys.